The objective today, we want to be able to solve one-step inequalities using addition and subtraction. Let's take a look at our first example. We spent a lot of time solving equations already this year, and the same processes, the same steps that we use to solve equations, we're going to use those same steps to solve inequalities as well. So this should be pretty simple. We're going to be using the addition property of inequality, which says when you add the same number to each side of an inequality, the inequality remains true. All right, well, what does that mean? It means that if you have the inequality 3 is less than 5, and you add the same amount to both sides of that inequality, here's the inequality, left side of the inequality, right side of the inequality. If I add the same amount to both sides of the inequality, I still get an inequality that's true. 5 is less than 7. And I can use that addition property of inequality to find solutions to an inequality. Here's an unknown value. Some number when we take away 4 has to be more than 5. To find that missing value, I use the opposite of whatever operations we see. I see subtraction, so the inverse of subtraction would be addition. We use the addition property of inequality to add 4 to both sides of that inequality. I find my solution. The value that makes that inequality true would be any number more than 9. Graphically, that would be 9 on the number line, circled but open, and arrow going to the right, showing that all the values to the right of 9 on the number line are going to make that true. We also have the subtraction property of inequality, which says when you subtract the same number from each side of an inequality, the inequality remains true. We start with the same inequality. 3 is less than 5. And I take away 2 from both sides of that inequality. I still get an inequality that's true. 1 is less than 3. We can use that same property of inequality to find a solution to an inequality here. Some number, when I add 4, has to be more than 5. And we're looking for what that number would have to be. So I see addition in the inequality. I use the inverse operation to find the solution. So I subtract 4 from both sides of the inequality. My solution says x has to be greater than 1. What does that look like graphed? 1 is circled on the number line. It's an open circle. Everything to the right is filled in. Now I neglected to say we should check our solution. So I pick a value that is in my solution set, right? 3. 3 is to the right of 1 on the number line. Let's check it. By replacing x with one of these values, see if it's true. Is 3 plus 4 greater than 5? Yes, it is. Could have done the same thing here. Our solutions say that x has to be more than 9. So I pick a number that's more than 9, let's say 12. I replace x with 12. See if I get something that's true. Is 12 minus 4 greater than 5? And the answer to that is yes. So you should check your solutions to your inequalities as well. This way you know if you're right or if you're wrong. All right, so let's take a look at our steps. It's real simple. We look at our inequality. It says some number when we take away 3 has to be more than 1. I want to know, well, what value is going to make that true? I see subtraction in the inequality, so I use the inverse of subtraction, which is going to be addition. So I want to add 3 to both sides of that inequality. On the left side of the inequality, negative 3 and positive 3 are opposites. They're going to be 0. I always want you to write the 0, but I'm left with x has to be greater than 1 plus 3 is 4. If I have to graph that solution, right, I sketch my number line. We always have 0 on the number line. 4 is going to be to the right of 0 on the number line. We circle 4. It's an open circle. Anything to the right of 4 on the number line is going to make that true. Let me check a solution. So I'm going to pick something to the right of 4 on the number line. Let's try 10. Is 10 minus 3 more than 1? Yes, it is. Right? So I used my addition property of inequality there to find the solution. Right? Let's try some examples here. First inequality says some number when we take away 2 has to be less than 3. I see subtraction. I use the inverse operation to find the solution. The inverse operation of subtraction is addition. So I want to add 2 to both sides of that inequality. On the left side of the inequality, those are opposites. That's going to be 0. I want you to write the 0. You're left with x on the left side of that inequality is less than 3 plus 2 is 5. On the number line, that means that 5 is circled on the number line. It's an open circle. Anything to the left of 5 should be a solution. So I'm going to try, 3. 3 is to the left of 5 on the number line. Let's see if that's true. Is 3 minus 2 less than 3? Answer to that is yes. All right, let's try number 2. It says some number, when we take away 6, has to be greater than or equal to 4. I see subtraction. The inverse operation would be addition. So I want to add 6 to both sides of that inequality. On the left side of this inequality, those are opposites. Negative 6 and positive 6. It's going to give you 0. You're left with x on the left side of the inequality. Greater than or equal to 4 plus 6 is 10. So that means 10 is circled on my number line, but 10 is filled in this time because the inequality is greater than or equal to, which means 10 should be a solution. Right? And we shade anything to the right because that's the direction of my arrow. Well, let's check it with 10 and see if this is true. Is 10 minus 6 greater than or equal to 4? Right? Yes, it is, because 4 is greater than or equal to 4. Right? So that's going to work. Let's try the next one. It says 10 is greater than or equal to a number minus 1. I see subtraction, and the inverse operation of subtraction is addition. So I want to add 1 to both sides of that inequality. These are opposites. That's going to be 0. 10 plus 1 is 11. That's greater than or equal to x. Now, there's a little trick going on here. This is what's called a reversed inequality. What do I mean by a reversed inequality? Notice our first 2 examples. It was variable first, inequality symbol, then number. Second example, variable first, inequality symbol, then number. Anytime an inequality is written with the variable first, the direction of the inequality symbol will be the direction of your solutions. Same thing with example 2. The inequality is written variable first, so the direction of the inequality symbol is the direction of the solutions. All right? But notice example 3. Right? Notice the variable does not come first. You have to recognize that, guys, because if you don't, you're going to make a ton of mistakes if you don't recognize the reversed inequality. So I recognize the reversed inequality when the variable is not first. We have the number first. Right? Now, what's that look like graphically? Well, I still have to circle. I got to add an 11 here. Right? So I circle 11 on the number line, and that has to be filled in, right? Because it's greater than or equal to. But when you have a reversed inequality, the solutions are in the opposite direction of the inequality symbol. So my solutions are going to go to the left, right? But let's check that. See if that's true. So I want to pick something that is, to the left of 11. Let's try 7. Is 10 greater than or equal to 7 minus 1? Right? 7 minus 1 is 6. Is 10 greater than or equal to 6? Yes, it is. Let's try something to the right of 11, right? Those are non-solutions. Let's try something like 20. 20 minus 1 is 19. Is 10 greater than or equal to 19? And the answer to that is no. So if you check your solutions, you know you're going to be right. But you have to recognize the reversed inequality. Reversed inequality, your number comes first, variable comes second, and when you have a reversed inequality, the importance is the solutions are going to be in the opposite direction of the inequality symbol. Okay, let's look at our next example. I see addition. The opposite of addition is subtraction, so I want to subtract 6 from both sides of that equation. That's 0. 15 minus 6 is 9. Right? 9 is greater than or equal to x. What do you notice here? Reversed inequality, right? The variable does not come first. So when you graph that solution, you have to be careful with the graph. All right, I'm going to put 0 and then put 9 here. 9 is circled and filled in, right? But now we have to know what direction are the solutions. Because it's a reversed inequality, the solutions are going to be in the opposite direction of that inequality symbol. Solutions are going to be to the left, right? And if you're not sure, check it, right? Let's pick something that's to the left of 9. Let's do 0. Is 15 greater than or equal to 6 plus 0? The answer to that is yes. So you know you did something correct. Okay? You have your on your own problems here, right? Let's try it. We'll do each one. I have a number plus 3 is greater than 7. The inverse operation of addition is subtraction. So I want to subtract 3 from both sides of that inequality. That's 0. I'm left with x is going to be greater than 7 minus 3 is 4. All right. Notice it is not a reverse inequality because the variable comes first. So I can write 0. I can write 4. 4 is going to be circled, right? But it's an open circle, and the solutions are going to be to the right of 4 on the number line. Check it with an answer with a value that's to the right of 4 on the number line. Let's try 10. Is 10 plus 3 greater than 7? Yes, it is. Next example. A number plus 2 is less than 17. I see addition. The inverse operation is subtraction. So I want to subtract 2 from both sides of that inequality. On the left side of the inequality, that's going to be 0. Y is going to be less than 17 minus 2 is 15. Notice it is not a reversed inequality because the variable comes first. So I graph 0, I graph 15. Open circle at 15. Solutions are going to be to the left of 15 on the number line. Our next one, 16 is less than or equal to a number plus 9. The inverse operation, subtraction, that's 0. 16, and you take away 9 is going to be 7, less than or equal to m. What do you have to notice here? It's a reversed inequality, so we have to recognize that and graph accordingly. So I'm going to have 0, and I have 7 on the number line. 7 is circled and filled in. It's a closed circle because it's less than or equal to. But because it's a reverse inequality, the solutions are going to be in the opposite direction of that inequality symbol. Solutions are going to go to the left here, right? Solutions are to the left. Check it, all right? I'm going to pick 10 because 10 is to the right of 7, and our graph says the solutions are to the right of 7 on the number line. So let me try 10. Is 16 less than or equal to 10 plus 9? The answer to that is yes. Let's try something like this. A little bit different. First step here, we have to combine some like terms. 7 minus 3 is 4. So I'm going to write a number plus 4 less than or equal to 10. So we have one initial step here where I have to put these like terms together. 7 and minus 3 is 4. Then I can use my inverse operation here. Subtract 4. That's 0. And it's going to be less than or equal to 6. Right? I want to graph it. 0. Here's 6. It's circled and it's filled in. Solution should be the left of 6 on the number line. So let me try 0. Is 0 plus 7, which is 7, take away 3, which is 4. Is 4 less than or equal to 10? Yes, it is. All right. You guys can try these two on your own. All right. You can stop the video, give it a shot, see what they're going to look like. All right. I'd say recopy the equation, the inequality first, solve it, graph it, and do the same thing with number 2. All right. So I'm going to rewrite number 1 here. U, take away 6, less than or equal to 3. Do number 2 here. Z plus 15 is greater than 24. So I'd say stop the video and try it on your own, and then start it back up when you're done. All right, but I will continue. I see subtraction. Inverse operation is addition. So we're going to add 6 to both sides of that inequality. They're opposites. That's going to be 0. I'm left with a number is less than or equal to 3 plus 6 is 9. All right, I want to graph my solutions. So I have 0. I have 9. It's circled and it's filled in. right? Inequality symbols going to the left, so my solutions go to the left. I check it. Let's try, I don't know, 8. 8 is less than 9. Is 8 minus 6, which is 2? Is 2 less than or equal to 3? All right, yes it is. So that looks like that's going to work. Let's look at our next example. A number plus 15 is greater than 24. The inverse operation would be subtraction. So I'm going to use that subtraction property of inequality. But what mistake did I make there? Let's do that again. All right. When you see that you're adding 15, the inverse would be to subtract 15, not 14. Right, so I'm subtracting 15, that's 0. Z is going to be greater than 24. Take away 15 should be 9. Right? What's that graph going to look like? Here's 0. Here's 9. It's circle, but it's an open circle, and it's to the right. Let me try a number that is to the right of 9 on the number line, see if it works as a solution. Let me try 10. 10 plus 15 is 25. Is 25 greater than 24? Yes, it is. All right. I'd say, why don't you guys try these on your own? Right, get some practice. I'd say stop the video, do them on your own. See if you get them right. I'm going to continue though. Subtract 2, subtract 2. That's 0. So I'm going to be left with n is less than or equal to 3. 3 is circled and filled in on the number line. Arrow goes to the left. Let's check it. I'll try 0 is to the left of 3 on the number line. Is 0 plus 2 less than or equal to 5? It is. All right. Try the next one. I see subtraction. The inverse operation would be addition. So I'd start by adding 3 to both sides of the inequality. It's going to be 0. You're left with y is greater than 9 plus 3 is 12. Right? I circle 12 on the number line. It's an open circle. Solution should be to the right. Check it. I'll try 13. Is 13 minus 3 more than 9? The answer to that is yes. All right. Now let's take a look at some word problems. These can be a little tougher because you actually have to write your own inequality first and then solve it and then graph it, right? So it's an extra step here to come up with your own inequality. It says a marathon runner plans to run at least 55 miles this week. He has already run 42 miles. Write and solve an inequality to find out how many more miles he plans to run this week. All right, so it doesn't say to graph it. We don't have to graph it, but it does say write and solve. He's already run 42 miles. We don't know how many more miles he has to run, but it's got to be at least 55. Right? The key there, at least. At least is associated with the inequality symbol greater than or equal to. Right? So that's key that we use the correct inequality symbol. Our inequality has to have a variable, right? Because we're going to have to solve that solve for that variable. So I start with 42 plus some number has to be at least 55. Subtract 42. Subtract 42. That's 0. We get n has to be greater than or equal to, what's that, 13? All right? And there's our answer. Let's try the next example. Right? Another word problem. It says a restaurant can serve a maximum of 115 people. There are now 97 people in the restaurant. Write and solve an inequality to find out how many more people can be served. Once again, we're not asked to graph, but there are already 97 people in the restaurant. How many more people can be served? If the maximum is 115, well, maximum means we could have less than 115, we could have equal to 115, right? So that would have to be our inequality symbol, less than or equal to 115. So that's the inequality we would write. To solve it, use the inverse operation. So I'm going to subtract 97 from both sides of the inequality. That's 0. N is less than or equal to 115. Take away 97. What's that? 18. Right? And there's our answer. Okay, a couple more, and we'll be done. I think these are the last two we'll do. Right? Yep, these will be our last two. A flea market advertises that it has more than 250 vending booths. Of these, 184 are currently filled. Write and solve an inequality to represent a number of number of vending booths still available. There are 184 vending booths being used. How many more are available if it has more than 250? Well, more than would have to be greater than symbol 250, right? More than is associated with greater than. Subtract 184, subtract 184, that's 0. N has to be greater than. If I take away 184 from 250, what's that, 66? Right? Should be 66. So there are more than 66 booths still available. And our last one, you've already spent $24 shopping online for clothes. Write and solve an inequality to represent the additional amount you must spend to get free shipping. Well, to get free shipping, you spend $75 or more. So you have to think about what inequality symbol is going to be associated with $75 or more. You've already spent $24. How much more do I have to spend in order to get free shipping? Well, in order to get free shipping, you can spend more than $75 or $75. So it would have to be greater than or equal to as our inequality symbol. We'd start by subtracting 24 from both sides of an inequality. That's going to be 0. And it's going to be greater than or equal to, what's that? 1 and 5. So $51 more you're going to have to spend. All right? You guys are going to do some examples on your own now. Make sure you pay attention to when the inequality is a reverse inequality, because that's really where students make their mistakes, right? And other than that, and if you recognize the reverse inequality is when you do not have the variable first. The variable is on the right side of the inequality symbol when you have a reverse inequality, right? So just pay attention to that, and you guys should be good. All right? Good luck with that.